This is section 10.4, and we are looking at what is called disjoint and overlapping events. We need some definitions again. Your first definition is a compound event. Compound event is the union or intersection of two events. Now I drew some pictures here to give you an idea of what that means. I have event A and event B. This is item number 1. I have event A and B, and they actually cross over. So the union of A and B would be everything. Anytime you're talking about union, you're talking about everything that's involved. So it could be these dots out here in A, could be the dots over here just in B, but it also could be the stuff that overlaps them. So that is the union. In picture number 2, you see the intersection, and the intersection would be any items that are in both A and B at the same time. And in picture number 3, you show two circles, and the intersection is empty. Anytime you have something that is empty, that is called disjoint, when they have absolutely nothing in common. So this picture right here would represent disjoint, and the probability that A and B can happen is 0 because they have nothing in common. Two events are overlapping if they have one or more outcomes in common. Pictures 1 and 2 show events that are overlapping. Here again is your pictures number 1 and 2. A and B overlap, so here's where they have something in common. Picture number 2, circles A and B overlap, and again, here's where they have in common. So that is called overlapping. Two events are disjoint if they have nothing in common, and this is also called mutually exclusive. That's another phrase that you sometimes hear. When they do not have anything in common, is mutually exclusive. And that is specifically picture number 3, oops, wrong direction, picture number 3, where you have two circles, don't overlap, they have nothing in common. That is called disjoint. Now we have a formula, of course, so make sure you have your notes handy, get your cheat sheet out for your final, and add this one to your corner that you're using for chapter 10. The probability that A or B could happen will be probability of A plus the probability of just B minus the probability that A and B are both happening at the same time. So this piece back here is the overlap. Do your two things have anything in common? If so, you need to subtract that because you would have counted it twice. And the key word we want to remember also is that when we're dealing with probability, the word or always means plus. Or means plus, and means to multiply. If you're doing disjoint events, things that have nothing in common, when you do P, A, or B, it'll be probability of just A plus probability of just B. Subtract nothing. If they have nothing in common, then you won't be subtracting anything in the back. All right, a card question. One card is picked from a deck of 52. What is the probability that you have a 10 or a face card when you draw this card? Okay, so we have one event going on. We're only going to pick one card. What's the chance that it is a 10 or a face card? So if we use our formula, probability of A or B, our A represents the 10 and our B represents the face card. So I need probability of just A plus probability of just B minus the probability that it could be A and B at the same time. So let's try to fill in some blanks. Probability of just A. What's the probability that I will have just a 10? Well, if you look across, we have 4 10s in our deck. So the probability to draw a 10 is 4 out of 52. Plus, now I'm going to go to event B. Event B is the face card. What's the probability that I will draw a face card? Face card, remember, are the Jack, Queen, and King. So that would be this set right here, Jack, Queen, and King. There are 3 from each suit, so we have 3, 6, 9, 12 face cards. 12 out of 52 face cards. But then I have to subtract out anything that they have in common. Could I have a 10 and a face card at the exact same time? No. They do not have anything in common, so I'm subtracting nothing. So I'm just looking at 4 over 52 plus 12 over 52. And please try to remember to reduce your fractions. 2 goes into both, you're down to 8 over 26. You could go one more time, 4 over 13. And again, fractions are fine. You don't need to convert these into decimals or into a percent. You can leave your probability as a fraction. Next one is a dice question. We're going to roll a dice just one time. What's the probability that it will be less than 3 or greater than 5? So my question, what's the probability of less than 3 or greater than 5? Means, one at a time, what's the probability that it could be less than 3? Plus, what's the probability it will be greater than 5? Minus, could it be less than 3 and greater than 5 all at the same time? Well, when you look at your dice, remember there's only 6 choices on the dice, the numbers 1 through 6. If it's going to be less than 3, it's the numbers 1 and 2, which means 2/6. If it is greater than 5, that means it only could be the number 6. There's one chance that that could happen, 1 out of 6, minus. Now, can I be less than 3 and greater than 5 at the same time? Again, that answer is no, so this particular event is disjoint, and then I can just go ahead with my addition. 3/6, which would be 1/2. Card question again. What's the probability that I could have a face card or a spade? And again, you need to be thinking, do they have something in common? P face card plus probability it could be a spade minus could it be a face card and a spade? And again, I have a sample of the entire deck here if you need to look. Face cards, again, are the Jack, Queen, and King. And all the suits, I've got 3, 6, 9, 12 again. So face cards, I've got 12 out of 52. Plus, spades. Spades is everything in this column. There are 13 spades in the deck, 13 out of 52 minus. Now, can I be a spade and a face card at the same time? Well, if I look at my spade column and I look at the face cards, yes, there are 3 face cards that are also spades. So I need to subtract those 3 out, and then I can come up with my total. 12 plus 13 is 25, minus 3, 22 out of 52, 11 over 26. Back to a dice question. We're going to roll a dice. What's the probability that it is greater than 4 or even? Using my formula, it must be greater than 4 plus probability that it could be an even number minus the chance that it could be greater than 4 and even at the same time. Greater than 4. Well, the numbers greater than 4, 5 and 6. 2/6 would be my probability, yes over total. The chances that it is even, my even values, 2, 4, and 6. There's 3 numbers, so the probability of an even number is 3/6. And do they have anything in common? Could it be larger than 4 and even at the same time? Yes, if I draw the 6. So that's one chance out of a possible 6. 2 plus 3 minus 1. 4/6. Probability of being greater than 4 or even 2/3. Next question. 100 students are surveyed. 92 own a car or a computer. 65 have a car. 82 have a computer. What is the probability that they have a car and a computer? So we need to write the formula. P, A or B. Oops, wrote that wrong. P, A or B is equal to probability of just A plus probability of just B minus the probability that it is A and B at the same time. So those are the 4 places that I need to fill in the blanks. Now I'm going to take my numbers that they gave me, fill them in. I'm not going to have one of them, and I'm going to need to solve for that x. We've got 100 students total, so I'm going to be writing these as fractions as we go, or you could do decimals as well. We're out of 100, it'll just be 0.92, 92 out of 100, and so on. All right, so 100 students are surveyed. 92 own a car or a computer. That's going to be on the left-hand side. 92 own a car or a computer, so I'm over here. 0.92 equals. 65 have the car, so just the car, that would be just A. 0.65 plus 82 have a computer, so that's just B. 0.82 minus, and I don't know, that's what I'm asked. What is the probability car and computer? I need to find this, so I'm just going to shortcut and call that X. I need to try to solve for X. 0.92 equals 0.65 plus 0.82 minus X. We're going to move the 65 over, we're going to move the 82 over. Negative 0.55 equals negative X. Divide out the negative sign, X equals 0.55. So the probability that they have a car and a computer, 55 over 100. And you could leave it at 0.55. You could write it as 55%. Every one of those answers would be okay. Now the last thing that's in this particular section talks about something called a complement. So here's one more definition and another formula for you to put in your notes and on your cheat sheet. Complement of an event are those outcomes not in A. I'll typically refer to them as the leftovers. The notation that we use for complement looks like this. Probability of A, but the A has a bar over the top. But when you read it, don't say A with a bar over the top. Read it as the word, the complement of A is equal to 1 minus the probability of A. 1 here represents the whole. So remember with probability, we're talking about percents and decimals. The highest you could ever get is of 100%. 100%, if I move my decimal 2 spots, is the number 1. So this 1 right here refers to the whole. And if I could figure out the complement, I'll do the whole minus whatever the probability is that I'm looking for. So it's the leftovers. Samples. Card question. A card is drawn at random from a deck. What is the probability that it is not a 7? What is the probability not a 7? Well, to figure out not the 7, I can just calculate 1 minus the probability that it is a 7. Well, how many 7s are in my deck? 4. 4 out of 52. So if 4 of the cards are 7, then how many are not the 7? Just do your subtraction. 1 minus 4 over 52, and if you need to look at it as the whole, 52 over 52 minus 4 over 52, 48 out of 52. That would be my complement. And again, you could reduce if you need to. Your next question. What's the probability of not a red face card? What's the probability of not getting a red face card? Which means I want to calculate 1 minus, yes, it is a red face card. 1 minus. What's the chance that I'll have a red face card? So if you think about your deck, face cards, Jack, Queen, and King, there's 12 total, but that's red and black, which means I only have 6 that are red. So 6 out of 52, and then I'll do my subtraction. 52 out of 52 minus your 6 out of 52, 46 out of 52 would be my complement, not a red face card. And then we could reduce again, 23, 26. And the other way you could see your answers is in decimal form. If the probability of A is 0.37, what's the complement of A? Well, you're still going to do the same thing. Your complement is 1 minus the original. And they gave you the original. The original is 0.37. What's 1 minus 0.37? Complement would be 0.63. Okay? So again, lots of formulas to put in your notes and on your cheat sheet. Complement formula, right here. put the word next to it so you remember what it is. And let's see. Right here. This big guy right here. One event, one thing is happening, you're going to draw one card, you're going to look at one color of a marble or whatever. So it's PA plus PB minus PA and B, both happening at the same time. That's it for section 10.4.